order. Why do you need to take so much time? Which one depends on which? Make it quick. Which one depends on which? Why? You can answer the previous question, but not this. So I presume you guess. Which one depends on which? Customer and order. Jerry, tell me a relationship between customer and order. Which one depends on which? We have 4 objects. Well, some might be have more than, right? So, which one depends on which? Customer and order. Katie, which one depends on which? Not here. Which one depends on which?
Orders depends on customer.
Order depends on customer.
Yeah.
Because from the diagram, then it said order depends on customer. Why do you say so? Colin, is that right? Order depends on customer. Why? Can you see that? I cannot hear. Because what?
I think the order is customer to order, and order is exist.
No, you don't tell me that. From the diagram. Yeah. You have the line, right? And the arrowheads, right? The arrowhead toward customer, right?
Yeah.
So if we don't know anything, right? And from this we understand the relationship. Arrowheads. Then prove it, Colin. Then I give you the So would you tell me that? How come it says order depends on customer? Prove it. Here is the order. Your customer. Tell me that. You said order depends on customer. From their attributes, tell me. And now we don't have any line, right? And I give you this, and which one depends on which? So
Customer.
customer what?
Order.
Customer.
orders.
Order what?
Orders customer.
Order what? Order. It's an order. Then
Customer.
order has customer. You can see the data type. All right. All right. And here about this two, which one depends on which customer and order list?
Customer depends on customer depends on order list.
How do you know?
Order no. Is order no?
What?
Because the create order list.
No, I said variable. Variable.
Orders.
Order. Which one order? Use an order. Order. Okay, Harry?
Its customer depends on order list.
How do you know?
Because if you don't have order list, the method creates order list can run.
No, tell me the variable. From the variable.
Variable is order list. Orders.
Order.
Orders.
Orders or orderless?
Orders.
Orders.
Yes.
What is orders?
Yeah.
How come you, from orders you understand that? No.
No. Also, it's not.
No.
No, it's from
I
create
think-
order list.
No.
No.
Yeah, I can give it a different name. It should be very obvious, you know. But order depends on customer. No, I talk about these two. Customer and order list. Customer and order list. So who depends on who? How do we know? This one. Yeah, that's right. All right. So that's the data type, order list. All right. And this, it's better, you know, it gives lowercase. All right. Lowercase. Don't use uppercase. So we can use whatever name, but yeah, order list, data type. All right. So this is from here. So the same order list, right, depends on order nodes. So we have order nodes. Okay. So that is about the dependency. And this is the diagram, and here we don't have line, but we understand that if you wanted to draw a line, then you understand that the line towards order list and order list, towards order nodes, and order node towards order towards customer. Okay. Let me see. let's take a break here. let's proceed. This chapter talk about data management, right? Since we create lots of data, right? It could be different formats, right? Last week we talked about file processing, right? File processing, that is very easy to create file, right? So we process file, we might combine with different language, right? And here, file, right? So it is very easy to create. With suitable program that we can access data very quick, right? So file, easy to create, then file can be anything, right? Complex data formats, be image, audio, right? Many things, it could be file. So we create more file, than others, usually, unless you understand use database. But for personal use, usually you will not use database, right? So you have a lot of file. So it is still very commonly used. But object-oriented database, relational database, or NoSQL data stores, that usually they will be managed by company, right? And for personal use, usually you will not create that unless you wanted to conduct some research, right? So file is very commonly used today, right? And we talk about that you might have different data formats, right? So file is one, right? So file has its advantage and disadvantage, right? So when we create file, that we usually we will not think about data consistency, right? So a file may have a lot of duplicacy, right? So duplicacy is the problems of a file, right? In the past days, right, when the memory is very expensive, then it is a big problem. But now, memory has become very cheap, right? So this become less concern, right? So file processing could be produce a lot of duplicate data, and so if we wanted to manage file, so file itself, right, we don't need to consider that. If we wanted to manage file, so file processing, right, so we might create like table, right? So a file, just like table, but there's a lot of duplicacy. We know that, right? It's quite similar to relational database. We talk about table, but the table, I said data duplicacy, and we know that if we wanted to press an order, right? So we wanted to create a table, then the table, we have no idea how many items, right? So is 5 is enough, or 6 or 7, right? So it's not right. So here is the problem. That's why if we can't better utilize our data, then we will use database to manage that, right? And since we design by object-oriented concepts, right? So our problem domain, we presume that's object-oriented. So you're going to see that the problem domain, we have lots of object, right? So it's object-oriented. Even though we use object, create the data, right? But we might use different data formats, or we said as object persistence, right? So we might want to convert from the object, to other formats, right? So now here, our problem domain, so our problem domains object oriented, right? And wanted to map to relational database, right? Usually want to map to relational database. And here you can see, if object oriented, then we don't talk about the mapping from object, the problem domains based on object to object oriented, because they are the same, right? So object oriented database, we don't talk about the mapping because the same. And here comes up, you can see object relational. Right? Object relation is just in between object oriented and relational database. So it has both ends, right? You take the feature from both ends, from object and relational concepts, right? So object relational. So if I say that, Ian, object relational, can you see inheritance in object relational database? We talk about inheritance. Can you see that? No? No inheritance? And is this allowed to have multiple value in object relational? So the attribute has multiple value. So we said that's it is allowed to have multiple value that's for relational database. Now it's a relational. So multiple value. No. Relational, then it's object relational, multiple value. Lola, what do you think? Allows multiple value in object relational database, multiple value. Yes or no? Yes or no? Yes. Object oriented. Yes or no? Object oriented is yes. Object relational is yes. Relational. Also yes. What do you think? Object oriented, object relational, and relational. Are they allowed to have multiple value? What? Relational? Do you understand the question? Is this relational database? Yes? Okay, so here, this is a relational database. We can see tables, all right? So now here, order, all right? For example, here, order. Then we can see the field, order number, dates, customer ID, amount, tax, total, payment type. Then we think that, well, we should add order item, right? So we add order item. We can add order item and also here. So when I say that it is allowable to have multiple value. Yeah, order item, we need to have many order item, right? So can we have order item and then have multiple value? Yes. So yes, then we can have a lot of amount, right, in one field, right? No, but it's an item, yes. Why? Item, yes, but amount is a no. It's yes. So we have a lot of amount in the amount. Yes. Why? Why is it yes? So here, if there's customer, right? Last name, we can have delivery, right? Last name, a lot of last name in one field. In one field, not record, right? One record. Last name, as many last name inside last name. How come it's yes? So here we can see that's only one value, right? So we can insert, right, the field, but whatever we want to insert that, right? I said that, well, customer will be address, right? So address. So Roland, customer has address, but customer have more than one address. How can we do? You say yes, then address, there's many address, right? How can we do that? Of course not. No, that's not. With the order, as many order item, we cannot add order item inside order item. No, of course not. Helen, tell me that. How can we deal with that? A customer has many address. A customer has many address. Do you know my question? A customer has many address. All right, address, many address. How can we? A customer has many address. Then? Yes, of course not. We cannot put it inside that. Now a customer has many address. How can we deal with this question? This relational database. Customer has many address. Raise your hand. You will understand that. Is that so difficult? Customer has many address. We are not going to put many address inside address. No. Alex?
Relational database, you need to insert new data in new row, which means each row just have a single value. It doesn't have multiple because it's violated normalization. You need to normalization. So you need to insert a new data for a new row. So the person may have one address, A address, and you need to insert a B address for the same customer.
So it has address 1, address 2.
Yes, you have address 1 for row and address 2, but it's the same customer.
If it's a 2 row, then there will be 2 record, right? No. Kevin? A customer has many address.
Create a new table.
Set it.
Like Alice say that.
What?
我的想法跟那个 Alex 一样，只是 create a new table.
No, that is that address column is row 1, address 1, and row 2, address 2. Do you understand that? So you said that, all right. Row 1 and row 2. Yeah, it's a that. I say if you have 2 rows, then it's 2 records. Then still 1 address, all right? Address 2. A field. What do you say address 2? Yeah? Okay? So you have 2 fields, address 1 and address 2. No. Get it? So this the
I
same as
think-
file processing.
I think we can create a table and it is for address and use the customer ID to find the address.
So we create another table as address, right?
Yes.
So we have many address, right?
Yes.
But customer ID may have different address, right?
Yes.
So they have a link, right?
Uh,
Yeah, we cannot put it in one table, right?
in one table.
No, we cannot put it, right? So you said create another
Yes,
table that's address.
yes.
So then we become 2 tables, right?
Yes.
Use key to connect that.
Mm.
Yeah, that's right. Right. So here, if we call this as a repeating, right? Data repeating group. A customer course can have more than 1 address, right? But you are not going to put address inside that, right? Inside a field, or you create address 1, address 2. No, not that. We need to create another table of address, right? And use key to link it, right? So that's what relational data base should be, right? So now here we cannot see address, but if we wanted to have address, but the same as the thing that whenever we need to have multiple value, right, then we take it out. And what we call it a normalization, right? Okay. But you can see that we use key, all right? So here, customer, right? Order, payment type, right? So before we can see different table, probably you lump sum and ones, you know, like a file, right? File processing. And we know there's a problems about it, so we wanted to change that, right? So we can see that it's a data consistency. And the data consistency, we call it referential integrity. So reference, referential integrity. So keep it consistent. So when we refer to a customer number, right? So that customer number, we can change customer inside that main table, all right? And the other table refer to this, all right? When it change, that will affect all the related table, right? So this is what we use relational database. So relational database, we have key, all right? Use key to join different table. If we need the data from more than one table, then we need to join. But when you join, it takes time, to processing, to join. So probably, would make a lot of effort, toward third normalization, right? And then eventually find it out that, well, the performance is not good enough. So we'll reverse it. The normalization, right? So this is normalization, denormalization. probably wanted to combine, combine it, or we put some data inside the one who needs it, right? So that's referred to refactoring, right? So here, then this is about relational database, but all the way we talk about object-oriented, we don't have this kind of concepts, right? We don't use key at all, right? We use key, but you can see that when you see the customer depends, so it depends on order list or habits, the variable. So that's difference, right? But here, habits, so this concept just like foreign key, right? So customer has the order list, right? So like the codes, I told you that LOD, so think about LOD. I wanted to ask, right? So dog want to take students, right? And perform the method of students, then here, get as a parameter, right? So here that is similar but not the same. So here comes the issue that we wanted to conduct mapping, all right, from problem domain to relational database. Manually, you need to do the mapping, but it's kind of, hard, or you might miss this part or that part, right? So that's what we are going to use some tool to help us. We call this ORM, right? So we will see that. I gave you the PowerPoints, right? ORM for the mapping, right? So it's mainly that's from object-oriented to relational database, but something in between. I just said the object relational. So object relational, you can see multiple value, right? Like object, but not relational. So that's difference. Relational database, it's not allowed to have duplicate value in one field. So I ask you that if customer has many address, then how can we do it? Many address. So address will not put inside customer. You're going to create another table. So we just talk about relational database and object-oriented database. They are different in some way, but similar in another. We wanted to do the mapping, then they are not exactly the same. So they will have mismatch. We call this impedance mismatch. Object relational, right? Impedance mismatch. So we talk about this. So yeah, object relational impedance mismatch, or we call this impedance mismatch, right? Because object is different from a record, right? And so a class can have many objects. A table can have many records, right? There's similar concepts, but we can see that if it's a relational database has a lot of record, right? So we give we give the order record a name at the customer, right? Customer. So a table. So this table name customer. In relational database, then here, that's it, right? A customer table. And the problem domain that we have customer class, all right? So we have a class, and that class can generate many objects. So each object like a record, a field, right? So the field, that's a data and attributes, that's right? So part of that, they are similar, but when we wanted to convert object to relational, then something we we should care, all right? Care about the difference, right? Care about something that's mismatched, right? And to think about a way to solve it. All right. So here, so that's select object model, right? So you can see the graph of object. We have 5. It says graph object, so it means that we have 5 object here. So object model. We have ID1, ID2, ID3, ID4, ID5. All right, we have 5 objects. Of course, if we wanted to use relational database, then we have 5 records. All right, and it might give us an if it's ID, right? So here we use object ID. All right, object ID should be unique. All right, like primary key of relational database is a primary key to identify a particular object. All right. Primary key should identify particular record. Record is an object for that. Okay. So here we can see, so your left hand side, so the diagram object model. Right. So now we can see 5 objects. 5 objects has its unique ID. ID1, ID2. So here, that's the ID. If we can see if two object has the same value, right? 2 object has same value. Usually we see that object has same value. Then semi, would that be the same? We said 2 objects. You guys, you can. We don't have your name. 2 objects. Now we have 5 objects. If 2 objects has the same value, then can we say that they are the same? How do we describe 2 objects are the same? There could be 2 aspects, right? When we describe or wanted to say that 2 objects are the same, what does it mean? 2 objects are the same. Hank, 2 objects are the same. If 2 objects are the same, what does it mean? The what? Data type, yeah. And when we say 2 objects are the same, what does it mean? And here, if 2 objects, right, we have 5 objects, 2 objects have the same value. Are they the same? They are not the same? Are they equal? We talk about object equality. Equal, right? Same. Yes or no? No, so they are not equal. They have the same value. How come they have same value but not equal? Harry,
They are equal but not the same.
what do you mean it's the same?
Because not same but equal. Because it's
Yeah, what do you mean the same?
the
Meanings of the same.
because they don't have the same ID, object ID.
Okay, if they have same object ID, then they are identical. They are the same. Shan, if two objects have the same ID, are they identical?
I think if they have the same ID, they will be the same.
They will be the same.
But without the same ID, they will maybe it will not be the same. Like we have a order, and the same customer have two orders, and they are buying the same thing and the same amount. The value of them is the same, but the ID is not the same. So it's a different meaning. But if the ID is the same, and it's
They are identical.
they are same. They are
Mhm.
equal. Yes.
So, and wait, here, yeah, you say if two objects have same ID, then they are the same. If they don't have the same ID, right, but the content, the value are the same, then
They are equal, but not the
they're
same.
equal. So they're equal, right?
Right.
Pretty good. Right. So here comes about when we talk about sameness. One is that they are totally the same. No, not to mention their content. If they are totally the same, of course, they are equal and they are the same identity. All right. But if they don't have the same ID, so only value the same, so they are equal. But they are not identical, so identity is not the same. The difference. Identity, here, we give it an ID, if it's the same identity, that means they came from the same address. We store it's the same address, all right? Unless we change the address. So the address, if we change that, right, change the address, and this object, right, this object will change. We may delete it and create it again, whatever. But whenever this object, and we talk about the data, well, these two are the same. No matter we change the address, it become different address, different ID, but they are the same. All right. So yeah, that's the identity and equality. If they are equal, doesn't mean that they came from the same address. Okay. Granularity. So here we need to compare granularity, all right, to see, how detailed that it will be, all right, granularity. So one is object-oriented, and the other, we always compare these two. The other, that's relational database. All right, so as table, right, table, and here we have object, right. So granularity is the extent that we just extend to broken down into smaller pieces. All right. So which one has a higher granularity than the other? Which one is higher granularity than the other? Things TA probably has already talked this issue, right? So you have already described this part. Penny, granularity. Do you understand that? So granularity can go to the smaller pieces, broken it down to smaller pieces. We can break down to smaller pieces. Okay, Harry.
sorry, but I want to ask a question. Is your question is what is granularity, or
No,
which part is granularity is more harder, or what?
high granularity.
In this diagram,
No, I asked not in this diagram, but talk about the relational database and object-oriented.
can you speak slower?
Object-oriented and relational database. We compare these two, right? The mismatch. So regarding regularity, right? Granularity, object-oriented is a higher granularity or relational database. This is that.
Let me think. Wait.
You can answer this question. This is very hard. So then would you explain this concept?
I think object is more higher granularity because, for example, person can maybe break down, person can have maybe address and order. So that is the smaller part. So I think object can have more higher granularity.
You said that, and then I'm going to ask you, relational data, so we have person, we have order, we have address table. Yeah, different table, and we link them, right, like this. Then they are the same. So we have person, right? This is different, right? So we have table, person, we have order, we have address. They are the same. So when you said that's higher granularity, which part? So here it says granularity is the extent to which a system can broken down into smaller parts. So now here, give us an example that a person could be a table, right? Table, and here that is a class. So person has address, right? Is this a composition? Person has address, and person has a relationship to order and another billing detail, right? But when we change to relational database, it seems not difficult at all. They are the same. What does it mean here? That object higher granularity. The different, right? A different classes, a different table. So we talk about similar thing, right? We talk about similar thing. No. Yes, Harry?
I think object-oriented is more high granularity, because object-oriented will make system to different small class, and the class only have do one things, or so do things, or is more sparters, and the relation database is different tables, but the tables maybe is more attributes and behaviors is behaviors to
Behavior?
how to say
So it's a relational database as a behavior.
no, it's not I mean my means is more like object oriented is more the spirited the
It says it contain more data. Relational
more
database.
like only do one things and
But then, okay, if that is text, all right, we have a table, text rates, right? State and text rates, only this. It's only text rates, right? And here, person is just one data, right? Everything that's related to person, right? And we go to relational table, the table related to person. If text, you know what it means, or it's a zip code, right? It's a table. It's only zip code. It's a table, all right? So it could be thousands of data, it could be, you know, a little bit of it. So they're quite similar. How come we said that granularity? So from this diagram, we can convert it to relational database. So Tim, can we convert it to relational database? Almost the same? We have 4 tables, right? So then see why you wanted to answer this. Table could be very simple. Table, look up simple. Look at table, right? Zip code. Text rate. Look up table, right? It's very simple, right?